Hi, IC120. I decided to choose an article that was based around assembly lines, seeing that we have a lab where we have an assembly line when making the trail mix, and we learn a lot about it in class. Furthermore, we discussed in class how we can improve this assembly line. My article is by Daria Bettini. It's called Assembly Line Balancing with Ergonomics. She starts with her article by stating that there are a lot of elderly individuals in the workplace. We do not want to lay off these individuals because they are talented. They just can't adapt well to the new technology. They are also in hazard of injury. And so by making their workspace more ergonomic, they're able to work longer hours and be in a safe environment. And so she states here that ergonomics of a system needs to be deeply analyzed and coupled with the time and methods analysis. In this article, Bettini uses an assembly line of cleaning products. There are 17 steps she must complete in order to finish her process. There are two methods she uses and describes. What's unique about these two methods are that they not only optimize the process, but they also pinpoint where she can make her process more efficient. This is through the use of Pareto charts. The first method she goes over is a multi-objective optimization approach. This distinguishes the objective function linked with assigned workload. This approach is common in science-related areas, and especially when optimizing a system. The first method is more complicated and daunting. The second method she discusses is more simple and something that we may be able to relate to. It includes an algorithm that transforms the energy expenditure during a task to a rest time. Both work well in this type of assembly line or manufacturing environment. Following, I will display the equation that she used in her experiment. For both processes, there are 4 steps she takes. For the first method, she starts by calculating the mean working time for each task by a times and method analysis technique. The second step, she calculates the energy expenditure to be assigned to each task by using the formulas I've shown you. Step 3, she expresses the same objective function in time and energy, thus defining 2 objective functions. Step 4, she solves the bi-objective problem by defining and mapping in a graph all the feasible solutions and the balancing designs belonging to the Pareto frontier. For her second method, she starts the same way with the first 2 steps, which are step 1, calculate the mean working time for each task by a times and method analysis technique. She then calculates the energy expenditure to be assigned to a task by using the formulas I previously showed you. Step 3, she transforms the task energy expenditure rate of each operator into rest time by using the formulas, again, the ones I've shown you before. Step 4, she minimizes the single objective function expressed in time and defines the optimal balancing solution. There are a few areas of this article that I wanted to bring to your attention. Each of the following components, I believe, correlates with our class, whether it be the lecture or in the lab. The first being the efficiency and optimization of a system overall. That's something that we continuously go over. The second component is making the worker's environment more comfortable, especially safe. After having our guest speaker the other day, safety seems to be a big issue. And having workers that are elderly, as Bettini focused on earlier, this would be a very important component to implement. The third component that I wanted to bring to your attention was that she uses energy to pinpoint certain areas that could be improved. Although in our lab, we do not pinpoint by energy expenditure, we use the Borg CR10 to determine how difficult a task was, or the overall process of making the trail mix. The last component that I wanted to bring to your attention was that Bettini implements a precedence diagram. This is a little more recent information that we learned in class, but she uses it to reorder her assembly line to make it more efficient and to eliminate slack time and bottlenecks. I hope this furthered your understanding of why ergonomics should be implemented. So thank you for watching, and go and read the article.